Welcome back to another chemistry tutorial from me, Miss T, a qualified teacher, Oxford University graduate, and your friendly neighborhood online tutor. This video works through calculating moles in aqueous solution with some worked examples and questions for you to try at the end. To start with some definitions, concentration is the amount or mass of solute dissolved per unit volume of solvent. So a solute is the substance that's being dissolved, and the solvent is the substance the solute is dissolving in, typically a liquid. So we've got two possible units for concentration, moles per decimeters cubed if it's amount, or mass per decimeters cubed, grams per decimeters cubed if we're dealing with mass of that solute. So for example, if this volumetric flask contained 1 decimeter cubed of water and has 3 moles of solute dissolved in it, the solution will have a concentration of 3 moles per decimeter cubed. We can link it together using this expression, number of moles equals concentration times volume, where concentration here is in moles per decimeters cubed and the volume of the solvent is always in decimeters cubed. Again, you must be able to rearrange this, so concentration equals moles over volume, or volume equals moles divided by concentration. So onto our first worked example, calculating concentration. 3.0 grams of sodium chloride was dissolved in 100 centimeters cubed of water. Calculate the concentration in grams per decimeter cubed. So first, we need to make sure that our volume is in the correct units. So dividing our centimeters cubed by 1,000 to get into decimeters cubed. So 0.1 decimeters cubed as our volume. As we're calculating our concentration in just grams per decimeters cubed, really straightforward, we divide our mass in grams by our volume in decimeters cubed to give us an answer of 30 grams per decimeter cubed. For part B of that same question, if we wanted to instead calculate the concentration in moles per decimeter cubed, we still need to make sure that our volume is in the correct units. We find our moles as mass over MR, mass being 3.0 grams of sodium chloride, and the MR of sodium chloride calculated as 58.5 from the periodic table. And that gives us 0.051 moles, lots of numbers after that I'm going to keep in my calculator, but just write down the first couple of numbers here. So concentration, moles over volume, 0.051 divided by 0.1, which gives us 0.51 moles per decimeter cubed. Worked example number 2, how many moles of HCl in 250 centimeters cubed of a 0.01 moles per decimeter cubed solution? So here, as we're calculating moles, moles equals concentration times volume. We need to make sure that our volume is in decimeters cubed by dividing our volume by 1,000. And then, nice and straightforward, we end up with an answer of 0.0025 moles, or 2.5 times 10 to the minus 3. Next worked example, what volume of water in centimeters cubed is needed if 1.75 grams of potassium nitrate is to be dissolved to produce a 0.50 moles per dm cubed solution? So to find volume, volume equals moles divided by concentration. Moles equals mass over MR, so 1.75 divided by 101.1. So then to find our volume, 0.0173 divided by 0.50 to give 0.035 decimeters cubed. The question specifically asked, however, for the volume in centimeters cubed, so multiply that value by 1,000 to give 35 centimeters cubed. For our final worked example, I promise, determine the final concentration of a 75 centimeters cubed solution of 0.40 moles per dm cubed HCl, which is diluted to a volume of 300 centimeters cubed. Now, for dilutions questions, we are not adding anything except water. So the number of moles of the solute haven't changed. And so N1, or the initial moles, are equal to N2, the final moles. And as N equals C times V, we can produce the expression C1V1, or the first concentration times the first volume, is equal to C2V2, the second concentration multiplied by the second volume. So substituting in our values, we can get 0.40 times 75 equals C2 times 300. We can then rearrange to make C2 the subject, and that gives us a concentration of 0.10 moles per decimeter cubed. Notice we didn't have to convert our volumes into decimeters cubed because dividing by 1,000 on both sides would just cancel itself out anyway. We could also take a bit of a shortcut and just see from our volumes that the value has increased by a factor of 4, from 75 centimeters cubed to 300 centimeters cubed. And because the volume has increased by a factor of 4, our concentration is going to decrease by a factor of 4. So that would already tell us that our new concentration would be 0.10 moles per dm cubed. So now it's your turn to have a go at these 3 questions. All of the relative atomic mass values that you need are over to the right. Pause the video now and press play when you're ready with your answers. For our first question, calculating the concentration, we start with calculating our moles as mass over mR, and that gives us 0.1 moles of our H2SO4. Then concentration equals moles divided by volume. Our volume was already given to us in decimeters cubed, so we don't need to convert that. Just simply 0.1 divided by 0.4 to give us 0.25 moles per decimeters cubed. For our second question, what mass of ammonium chloride is required to prepare 21.5 centimeters cubed of 0.10 moles per dm cubed? So first we calculate our moles as concentration times volume, which gives us 0.00215 moles. Again, making sure you first converted your volume from decimeters cubed to centimeters cubed. Then to find the mass, mass equals moles times mR. So 0.00215 multiplied by 53.5, which gives us 0.115 grams. And finally, calculate the volume of 2 moles per dm cubed HCl required to make 0.5 dm cubed of 0.25 moles per dm cubed diluted HCl. So as this is a dilution question, the number of moles at the beginning and the end stay the same. So we use C1V1 equals C2V2. So 0.25 times 0.5 equals 2.0 times V2. Rearrange, and that gives us a volume of 0.0625 decimeters cubed, or multiply by 1,000 to give 62.5 centimeters cubed. So how did you do? If you have any questions, want anything to be explained a little bit further, or would like a video on a particular topic, please make sure to leave a comment down below. Thank you so much, and see you next time for another Miss T Chemistry tutorial. Bye.